So here's one last example to sort of bring everything together. I've got two congruent triangles here that are congruent through side angle side congruence. And there's this property that extends from all of these congruence criteria called CPCTC, which stands for corresponding parts of congruent triangles are congruent. So once I've shown through side angle side the triangle ABC is congruent to triangle PDG, that means all of the corresponding parts are going to be congruent. Line segment BC will be congruent to line segment GD. Angle B will be congruent to angle D. And angle G will be congruent to angle C. So even though I didn't show that those things were congruent initially, because I've shown that the two triangles are congruent through side angle side congruence, then all of their constituent parts, all of their angles and all of their sides, their corresponding angles and their corresponding sides are going to be congruent as well. And remember, we would have to write that in a congruent statement where the letters match up. So triangle ABC is congruent to triangle PDG. And notice here how angle A and angle P are congruent in both the diagram and the congruent statement. Angle B and angle D are congruent in both the diagram and the congruent statement. And finally, angle C and angle G have the same corresponding pieces in both the notation and the diagram. And then you can draw a similar connection here. Line segment AB was congruent to line segment PD. And look here in the diagram, AB and PD are grouped together. And of course, the same is true for line segment BC and GD, or DG rather. They're grouped together in the diagram. So corresponding parts of congruent triangles are congruent, and order matters when you're writing your congruence statements.